the laws of black hole mechanics, inspired by the principles of thermodynamics. Let's talk about that, and let's have some conversation. So these laws were formulated by the physicist Jacob Stein, and these laws were extended later on by Stephen Hawking. So these laws draw basically the parallels between the behavior of black holes and the fundamental laws governing the macroscopic systems. So if we start with the zeroth law of thermodynamics, if we talk about the temperature of black holes, the temperature of event horizon of a black hole, and this temperature of event horizon is uniform, and its surface. This law establishes temperature, a constant temperature, a uniform temperature for black hole, which is basically a very pivotal concept in black hole thermodynamics. Then talking about the first law of thermodynamics, the change in black hole mass, okay, it is certainly related to change in its area and its energy, and this energy can either be added to the black hole or it can be subtracted. So this is analogous. This phenomenon is very much analogous to the first law of thermodynamics, and linking changes in energy to change is in mass and area. Now, if we go to second law, the second law of thermodynamics, and try to correlate it with the black hole, the area of black hole's event horizon, talking about its area, overall area, it never decreases, and this is certainly because of the second law of thermodynamics. And the second law of thermodynamics stating that entropy never decreases in an isolated system. So if entropy never decreases in an isolated system, then certainly there is this overall area of the event horizon remains uniform. Now, talking about the third law, that the temperature of the black hole approaches absolute zero. When should its temperature approach to absolute zero? When its mass approaches to infinity. And this is also similar to third law of thermodynamics regarding the unattainability of absolute zero. So because we understand from conventional thermodynamics that it's impossible to have circumstances where we can achieve a temperature equivalent to absolute zero. So here I talked about the parallelism between the laws of thermodynamics and the laws that are governing, the classical laws that are governing